Have you ever wondered how fire burns? What causes the mesmerizing dance of heat and light? Our journey today begins with the mystery of fire, an element as captivating as it is destructive. Fire, in its most basic form, is a chemical reaction involving three key components: oxygen, heat, and fuel. This process is known as combustion. Imagine a triangle where each side represents one of these components. Oxygen, a gas found in the air around us, combines with fuel under the influence of heat. Fuel can be anything that can burn: wood, gas, even certain metals. And heat, that's the spark that sets everything in motion. This is what we call the fire triangle. Each component is essential, and without even one, fire simply cannot exist. Remove the oxygen, the fire dies. Take away the heat, the fire goes out. And without fuel, there's nothing to burn. Without oxygen, heat, or fuel, fire simply cannot be. But let's delve deeper into this fascinating process. Oxygen, a gas that makes up about 21% of Earth's atmosphere, plays a vital role in the burning process. You see, when we light a fire, we're not just setting a match to a log. What's really happening is a chemical reaction, specifically combustion. In this process, the fuel, be that wood, paper, or propane, doesn't burn on its own. It combines with oxygen from the surrounding air. This union sparks a reaction that releases energy in the form of heat and light. It's this energy that we recognize as the warm, bright entity we call fire. The heat fuels the reaction, causing it to continue to stay alive, so to speak. In the absence of oxygen, this reaction can't take place. The fuel has nothing to react with, and thus no fire can be produced. So we can say that without oxygen, your campfire is nothing but a pile of logs. Now, what about the other two elements in this fiery trio? Let's examine the roles of fuel and heat. Fuel, as you might expect, can be anything that's combustible. This might be as commonplace as the wood in your fireplace or the gasoline in your car. But in a broader sense, it could also be something as unexpected as a potato chip or a piece of paper. Essentially, anything that can burn can be considered as fuel. What happens is that the heat, our second player, acts as the ignition source that starts the burning process. It's like the spark that lights the fuse. This heat breaks down the fuel into a gas, which then reacts with the oxygen we talked about earlier. This reaction releases heat and light, which we perceive as flame, but the role of heat doesn't stop there. It also keeps the reaction going. It's a self-sustaining process. The heat generated by the burning fuel continues to break down more fuel into gas, which reacts with more oxygen, and so on. It's a cycle that keeps the fire burning, provided there's enough fuel and oxygen present. Yet, if there's not enough fuel or heat, the fire won't sustain itself. Imagine trying to keep a fire going with just a few twigs, or if a sudden gust of cold wind blows onto your campfire. Without enough fuel or heat, the fire will simply extinguish itself. Ever noticed how fire isn't just one color? Here's why. When we observe a flame, we're actually seeing a variety of hues, each with its own tale to tell. This vibrant display is a result of the temperature and the material being burnt. Let's start with temperature. Lower temperature fires tend to emit a warm, red glow. As the temperature increases, the flames transform into brighter shades of orange and eventually yellow. The hottest fires can even produce an intense blue or white flame. This is because as the flame's temperature rises, it emits light at shorter wavelengths, shifting the visible color from red to blue. Now, it isn't just about temperature. The material being burnt also plays a crucial role in the color of the flame. You see, different materials contain different chemicals, and when these chemicals are heated, they emit light at specific wavelengths, creating distinctive colors. For instance, burning copper produces a green flame, while sodium gives off a bright yellow glow. So there's quite a bit of science behind the mesmerizing dance of colors in a flame. It's a spectacle of heat, chemistry, and light, playing out right before our eyes. Next time you sit by a fire, you'll know there's a lot more going on than just pretty flames. Fire, a product of oxygen, heat, and fuel, is truly a wonder of nature.